ಇವತ್ತು we'll be starting out with our data structures, VTU centric and exam oriented, uh, I would say playlist. So this playlist, which will be starting, will be containing some of these topics. ನಾನು ಹೇಳೋ ಪ್ರಕಾರ ಇದು ನಾವು ಡೀಪ್ ಹೋಗೋಣ ಬಟ್ ಅಂಟಿಲ್ ಅನ್ ಎಕ್ಸ್ಟೆಂಟ್ ನಾಟ್ ಟೂ ಡೀಪ್ ಬಿಕಾಸ್ ಇಫ್ ಯು ವಾಂಟ್ ಟು ಗೋ ಟೂ ಡೀಪ್ ದೇರ್ ಆರ್ ಬೆಟರ್ ರಿಸೋರ್ಸಸ್ ಅವೈಲಬಲ್ ಆನ್ ದಿ ವೆಬ್ ಟೀಚ್ ಬೆಟರ್ ದೆನ್ ಮೀ ಆಫ್ ಕೋರ್ಸ್. ಸೊ ಅದಕ್ಕೆ ನಿಮಗೆ ನಾನು VTU ಸೆಂಟ್ರಿಕ್ ಆ್ಯಂಡ್ ಏನು ಕೇಳ್ಬೋದು ಆ್ಯಂಡ್ ಎಕ್ಸಾಮ್ಸ್ ಬರೋ ಪ್ರೊಬ್ಯಾಬಿಲಿಟಿ ಆಗಲಿ ಆ್ಯಂಡ್ ವಿತ್ ಸಮ್ ಪ್ರೀವಿಯಸ್ ಇಯರ್ ಕ್ವೆಶನ್ಸ್ ಆಸ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್. ಸೊ ಈ ಥರ ಬಂದರೆ ಹಿಂಗೆ ಮಾಡಿ ಅನ್ನೋ ಒಂದು outline in the I can continue this topic. So for today, without any due, let me start with data structures, the classifications, their operations, main operations ಏನಿದೆ, and what are the main uh, ಇವತ್ತೇನಿರುತ್ತೆ ಅಂದ್ರೆ the review of pointers and dynamic memory allocation. This is again a basic ಅನ್ನಕ್ಕಿಂತ a fundamental concept which you have to know either it is for exam purpose or any other perspective. So if we start out with data structures, again, ನಾನು ವಿ ಟಿ ಅವ್ರದ್ದು ಅಥವಾ ಯಾರೋ ಪ್ರೊವೈಡ್ ಮಾಡಿರೋ ನೋಟ್ಸ್ನೇ ಯೂಸ್ ಮಾಡ್ತಿದ್ದೀನಿ and I will be providing some kind of outline with the notes. So ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಲಿ ಅದು what it actually means rather than just mugging up and going to the exam. Now let's start with the given notes. So basically, the note says that the study of how the data can be collected and stored in main memory during execution, how the data can be represented, how the data is organized, and how the data is categorized. ಅನ್ನೋದಂತ one kind of formal definition ಕೊಟ್ಟಿದ್ದಾರೆ. So if you think in the raw, if you want an intuition, what is data structure? Data structure, as the name ಹೆಂಗ್ ಹೇಳ್ತಿದೆ, it's structuring your data. Data's ever data, real world data ಆಗಲಿ ಯಾವುದೇ data ಆಗಲಿ, it won't be structured every time. It may be or may not be structured. So if we are able to structure data for our own needs, ನಮಗೋಸ್ಕರ ನಾವು ಯಾವ ಥರ ಬೇಕಾದರೂ ಮ್ಯಾನಿಪುಲೇಟ್ ಮಾಡೋದಾಗ್ಲಿ ಅಥವಾ ರಿಟ್ರೀವಲ್ಗಾಗಲಿ ಅಥವಾ ಕಲೆಕ್ಷನ್ಗಾಗಲಿ ಎಷ್ಟು ಫಾಸ್ಟ್ ಅಥವಾ ಎಷ್ಟು ಸ್ಲೋ ಅಥವಾ ಯಾವ ಮೀಡಿಯಂ ರೇಂಜ್ನಲ್ಲಿ ನಾವು ಈ ಆಪರೇಷನ್ಸ್ನ ಮಾಡಬೇಕಾಗುತ್ತೋ ಅಥವಾ ಈ ಥರ ಒಂದು ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಆಫ್ ದ ಡೇಟಾ ಮಾಡಬೇಕಾಗುತ್ತೋ ಆ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಆಗನ್ನ ನಮ್ಗೆ ಬೇಕಾಗಿರೋ ಡೇಟಾ ಆ ಸ್ಟ್ರಕ್ಚರಲ್ ವೇಯಿಂದ ನಾವು ಅದನ್ನು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಬೋದು. ಸೊ ಇಫ್ ಯು ವಾಂಟ್ ದ ಡೆಫಿನೇಷನ್, ದಿಸ್ ಇಸ್ ದ ಫಾರ್ಮಲ್ ಡೆಫಿನೇಷನ್, ಬಟ್ ದಿ ಇಂಟ್ಯೂಷನ್ ಇಸ್ ದಟ್ generally the data is raw. For our own preference, how we structurize the data will be our data structure. For let's say I'm a data engineer who wants to structure a data which is coming from user, let's say, history for YouTube. Let's say YouTube user history ಇದೆ, ನೀವು ಅದನ್ನ ಸ್ಟ್ರಕ್ಚರ್ ಮಾಡಬೇಕು. The user history will be a bit let us say there is no way to structure the YouTube history and you have to it is randomly coming to you through a data pipeline. So ನೀವು ಅವಾಗ ಏನು ಮಾಡಬೇಕಾಗುತ್ತೆ, you have to either store that in a form of table. Again, table ಏನಾಗುತ್ತೆ, it's a two-dimensional array. If you know what the upcoming, which will be talking about arrays and other kind of non-primitive data types, so data structures. So now again, you have to store it in a table, do you have to store it as a graph, do you have to, so it depends. Now ನಿಮ್ಗೆ ಯಾವ ಥರ ಬೇಕೋ ಆ ಥರ ಸ್ಟ್ರಕ್ಚರ್ಲಿ ಸ್ಟೋರ್ ಮಾಡೋಕ್ಕೆ ವಿ ಯೂಸ್ ಆರ್ ಓನ್ ಡೇಟಾ ಸ್ಟ್ರಕ್ಚರ್. ನಾವು ಅಗೇನ್ ಡೇಟಾ ಸ್ಟ್ರಕ್ಚರ್ ಅಲ್ಲಿ ಅದರದೇ ಅಂತ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಇದೆ. ನಾವು ಫಾರ್ ಪರ್ಪಸಸ್ ಆಫ್ ವಿಜುವಲೈಸೇಷನ್, for the visual learners, let's just use this kind of thing. Now again, it is written Java. If you want to see, it'll be similar. So primitive and non-primitive ಇದೆ. So numeric and non-numeric or any other kind of objects. Let's not get into the Java part. ಕೊಟ್ಟಿರೋ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಏನಿದೆ ನೋಡೋಣ. So what are the primitive data structures which we are thinking? Basically, primitive data structures are nothing but fundamental data types ಅಂತ ಅನ್ಕೊಳ್ಳಿ. Don't get confused here. These are those that can be manipulated directly by machine instructions ಅಂತ ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರೆ. Again, ಯಾವುದೇ data structure which can be directly handled by the machine instructions, like machine instructions can be move that variable from uh, xyz location to that location. Now again, you can do it for your non-primitive also, but machine instructions ಮಾತ್ರ ಯೂಸ್ ಮಾಡಿಕೊಂಡು without any your own instruction machine instruction ಮಾತ್ರ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು if you can manipulate any kind of data structure, now that data structure will be considered as a primitive data structure. Without getting in too deep, fundamental data types themselves are data structures. Now ಏನೇನ್ data types ಓದಿದ್ರಿ, something like integers, floating points, characters, double values, pointers, all these themselves are primitive data structures, also being primitive data types. So integers ಬಂದು ನಮ್ಮ 64-bit architecture it will be 4 bytes, and same goes for a floating point. So you can manipulate their size ಆಗಲಿ ಏನೇ ಆಗಲಿ directly using the machine instructions, because you can directly pick on those from your memory, or main memory or secondary memory, whatever it is. Now non-primitive, as the name suggests, non-primitive is basically ಆ primitive ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಮಗೆ ಬೇಕಾಗಿರೋ ಅಂತಹ non-primitive ಅಂದ್ರೆ complex data structures ನಾವು if you come out of those complex data structures by building us for our own use, that will become non-primitive. So use the primitive data structures and build our own non-primitive data structures. ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ, the definition says that it cannot be manipulated directly by machine instructions. Again, what they're trying to mean by that statement is that when you create your own data structure, or a data structure which is being used from the primitive data structures, you instead of directly machine instructions, ನಿಮ್ಮ instructions ಇಂದ ಮಾತ್ರ ನೀವು ಅದನ್ನ manipulate ಮಾಡ್ಬೋದು. Let's say you have using an array. Now again, array is not a primitive data structure, but it uses primitive data structure such as integers array ಆಗಿರ್ಬೋದು, character array ಆಗಿರ್ಬೋದು, floating point array ಆಗಿರ್ಬೋದು. Now so it is a non-primitive data structure. Now to traverse ಆಗಲಿ delete ಆಗಲಿ ಏನಾದರೂ ಅದು ನಿಮ್ಮ ಆಪರೇಷನ್, there is no direct machine instruction illa. So you have to understand in that perspective also if they ask in the exam. So basically, if they ask in the exam what is data structures and write data structures and write the data primitive and non-primitive types. ಇಲ್ಲಿ ಮಾಮೂಲಿ primitive data types ಏನಿದೆಯೋ ಅದನ್ನ ಬರೀರಿ. And the non-primitive, you can give simple examples like arrays, stacks, queues, and linked list entries. Since this will be first chapter in the question, alwa, I don't think so. You have to explain each and every data structure when you're giving the example. So you can just cite the examples and move on. Now, very important, what are the operations that can be performed on data structure? Now, again, now I'm just going for the sake of simplicity. Nano, I will consider an array for our example purpose, as you guys know that array is contiguous memory allocation. Just don't let's not go into that deep. So I'll just say what is an array. Array is just a non-primitive data structure which stores values in contiguous memory location. Contiguous ಅಂದ್ರೆ ಒಂದಾದ್ಮೇಲೆ ಒಂದು, even in the memory. So let's say if this is index 0, 1, 2, 3, and 4. So even in the main memory, it will be stored like this. It won't be scattered, or no complex algorithms are being used to optimize any kind of storage and retrieval. So array will be like that. Now let us take what will be the operations which can be performed on this array. Again, array is a non-primitive data structure, so ಇದ್ರ ಮೇಲೆ ನಾವು ಏನೇನೆಲ್ಲ ಮಾಡ್ಬೋದು. And since we are learning data structures in C language, we will mainly focus on that again. Now traverse ಮಾಡ್ಬೋದು. Traverse ಅಂದ್ರೆ let's say you have to find, you have to see every element of this array. So you have to traverse through the whole array. Traverse ಅಂದ್ರೆ ಅದ್ರ ಒಳಗಡೆಯಿಂದ ಪಾಸ್ ಆಗೋದು ಅಂತ ಅನ್ಕೊಳ್ಳಿ. So you're passing through that array. If you pass through that array, what and all can you come up with? So you will come up with this x, x1, x2, x3, x4, so on. So traversal ಇಂದ ಏನೇನು ಯೂಸ್ಫುಲ್ ಇರುತ್ತೆ? Let's say you have an array of books. You have an array of books, and if you have to find a particular book based on its ISBN number. So ನಿಮ್ಗೆ ಗೊತ್ತಿಲ್ಲ book ಎಲ್ಲಿದೆ ಅಂತ, but ನಿಮ್ಗೆ ಅದರ ISBN number ಗೊತ್ತು. So if you know that value, so you will come here, you will check if that's ISBN number, you will move from there to there if it is not. ಹಂಗೆ move ಆಗ್ತೀರಾ until unless you find. So now this is called again traversal or searching, or ನೀವೇನಾದ್ರು ಅನ್ಕೋಬೇಕು. That traversal is one of those main operations for which can be used for any kind of non-primitive data structure. ಯಾವುದೇ non-primitive data structure traverse ಅನ್ನೋ ಒಂದು ಪದ ಬಳಕೆ, I think it will be more often, because you have to traverse majority of the times, you have to keep on traversing. Again, inserting ಇದೆ of course, ಯಾಕಂದ್ರೆ ನಾವು array ಯೂಸ್ ಮಾಡ್ತಿದ್ದೀರಿ. You can insert in the, you know, parts where, even though you can use some kind of left bit shift or right bit shift use ಮಾಡಿ, you can use elements to traverse, insert in the middle. But usually in arrays, you always insert through the end or append ಮಾಡ್ತೀರಿ from the one end ಇಂದ ಮಾತ್ರ ನೀವು data or whatever the object is you can append for for the sake of example I'm using arrays for the operations, so again it will be different for different kind of data structures. Now deletion, again given the index you can delete that element for that particular index, so again you can traverse till that index. ಹೌದಲ್ವಾ? You can traverse till that index and you can delete that index and shift these elements if you want to save memory, or even though if you don't want. So it depends. Now again, searching. Again, ಅವಾಗ ಹೇಳಿದಾಗ same the library example. Let's say you have a stored book of a array of books, and you have to find a particular book. So you don't know the exact location in the array, but you know the ISBN. So you have to traverse through the array, and you for that given ISBN, you can search that book and retrieve that book. Sorting, sorting is a simple mechanism, I would say. Sorting, as the name suggests, let's say there are books which are in random order. Let's say the ISBN of this book is 123, but this is 456, and this is like 1036, and this is one. Now, if you just raw consider raw again, if you consider the ISBNs as the value by which you're sorting, so again, this is not sorted because one is the smallest value sorted by ascending, let's say. Sort by ascending ಅಂತ ಹೇಳಿದಾಗ then this becomes invalid. It is not sorted by ascending. So because one bandu last ಇದೆ. So if you think from left to right, if it is in increasing order, then it will be sorted, or else it's not sorted. So sorted, and it's sorting an array is again there are different sorting mechanisms which you can use. I won't go deep into that. And the sorting is to arrange the elements of an array to our own need. To our own need. Let's say there is an user application where he has to retrieve again the books, and he has to retrieve the books based on the book which was recently uploaded. So recently uploaded ಅಂದಾಗ ಅವಾಗ ಏನು ಮಾಡಬೇಕು? Sort by the date. So date ಅಥವಾ time, sort by date. Sort by date through descending ಮಾಡಬೇಕು. ಯಾಕಂದ್ರೆ recently ಅಂದ್ರೆ ಟೈಮ್ ಯಾವತ್ತು ಲೀನಿಯರ್ ನಮ್ಮ ಪ್ರಕಾರ. So when you think it's linear and you have to get the most recent one, so you have to again sort the books on their creation date by descending order. So you understood the application. If you can conceptualize any kind of concept through the application, I think you could remember rather than mugging it up. So ಹೇಳಿದ್ದು ಅರ್ಥ ಆಗಿದ್ರೆ we can move on from this point. Then again, definitions ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ. I will just skim through it. The process of accessing each element exactly once and manipulate it. So print the array, printing array array elements and print ಮಾಡಬೇಕಂದ್ರೆ of course we know the number of elements, and you can run through a for loop or a while loop. Loops use ಮಾಡಿಕೊಂಡು ನಾವು traversal ಮಾಡಬಹುದು, and you can display that. Now I told you more on the inserting part, the deleting part, and searching part, and sorting part. If they ask what are the operations that can be performed on data structure, main ಈ 5 ಗೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡೋ ಥರ ಒಂದು ಅಪ್ಲಿಕೇಶನ್ ಆ್ಯಪ್ ಕೈಕೊಂಡು ಹೋದ್ರೆ ಸಾಕು. ಐ ಥಿಂಕ್ you can do it on your own. Nothing to worry. This is since just basic concepts. Now again, traversing over one example ಕೊಟ್ಟಿದ್ದಾರೆ. It might be important. So you can just look through it. Again, you can give your own example. Not restricted to anything. Now, since we are doing data structures in C, C is that kind of language which was implemented at the early stages of uh, the computer era. So where the concept of object-oriented programming was not so familiar. So if you think in Java, right? Java ನಾವೇನಾದ್ರು ಮಾಡ್ಬೇಕಂದ್ರೆ ಕ್ಲಾಸ್ ಮಾಡ್ತೀರಿ, ಆ ಕ್ಲಾಸ್ ಇಂದ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಮಾಡಿ. ಸೊ ಇಫ್ ಯು ಆರ್ ನಾಟ್ ಫೆಮಿಲಿಯರ್ ಇಸ್ ಫೈನ್, ಐಮ್ ಜಸ್ಟ್ ಸೇಯಿಂಗ್ ಫಾರ್ ದ ಸೇಕ್ ಆಫ್ ನಾಲೆಡ್ಜ್. ಮಾಡಿ ಆಬ್ಜೆಕ್ಟ್ ಕ್ರಿಯೇಟ್ ಮಾಡಿ, ಆ ಆಬ್ಜೆಕ್ಟ್ ಥ್ರೂ ನಾವು ಅದ್ರ ಇರೋ ಫಂಕ್ಷನ್ಸ್ ಆಗಲಿ, ಡೇಟಾ ಟೈಪ್ಸ್ ಆಗಲಿ, ಡೇಟಾ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಆಗಲಿ, we could access. But in C, if you want to create your own data structure, let's say array, ಸರಿ array ನಿಮ್ಗೆ ಗೊತ್ತು. Again, array is also data structure, non-primitive. ಅದು ನಾವೇ ಮಾಡಿರೋದು as humans. We have come set through that, yeah, this is a good kind of data structure to store some kind of linear data. So, or ಆ ಥರ ನಾವು ಯೋಚನೆ ಮಾಡಿದಾಗ, so why do we use structures in C specifically ಅಂದಾಗ, let's say our array is a collection of similar items. Using array and other, we can handle variety. But in real world, yeah, this is a very good example ಅವ್ರು ಕೊಟ್ಟಿದ್ದಾರೆ. We can deal with entities that are collection of dissimilar data types, right? Name of the student, marks scored, average marks, right? So ಅದೇ ಎಕ್ಸಾಂಪಲ್ ತಗೊಳೋದ್ ಬದಲು ನಾನು ಒಂದು ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ತಗೋಣ, which is more interesting, I would say. Let's say we have a car, and we have to store the information about car. So the car has some kind of model number is there. It has model number, some kind of, let's say, some kind of manufacturing year, and even the company name, right? ಅರೇ ಬಂದು ಯಾವತ್ತು ಸಿ ಅಲ್ಲಿ ಅರೇ ಬಂದು ಓನ್ಲಿ ಸ್ಟೋರ್ಸ್ ಸಿಮಿಲರ್ ಕಲೆಕ್ಷನ್ ಆಫ್ ಸಿಮಿಲರ್ ಡೇಟಾ ಟೈಪ್ಸ್. ಅಂದ್ರೆ ಇಲ್ಲಿ ನಾನೇನಾದ್ರೂ ಇನಿಷಿಯಲೈಸ್ ಮಾಡಿದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಸೊ ನಾವು this array, this static array will be always the data type of int. ಸೊ ನಾನು ಬೇರೆ ಯಾವುದೇ ಡೇಟಾ ಟೈಪ್ ಆಗಲಿ ಆಬ್ಜೆಕ್ಟ್ ಆಗಲಿ ಏನೂ ಅಪೆಂಡ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ ಅಥವಾ ಇನ್ಸರ್ಟ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ ಇಲ್ಲಿ. So now this is restricted to int. But in real world scenario, again, this becomes an object oriented perspective of programming, right? So if you want to, you know, build a data type, a data structure which holds this single car's information here, car 1, car 2, car 3. Now this is different. ಸೊ ಅದಕ್ಕೆ ನಾವೇನ್ ಇವಾಗ ಏನಾಗುತ್ತೆ ನಮ್ದೋಸ್ಕರ ನಾವು ಅರೇ ಗೊತ್ತಾಯ್ತು, ಅರೇ ಇಸ್ ದ ನಾನ್ ಪ್ರಿಮಿಟಿವ್ ಒನ್, ಬಟ್ ನಮ್ದೇ ಆದಂತಹ ಇನ್ನೊಂದು ಅರೇ ಕ್ರಿಯೇಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ ವಿಚ್ ಕ್ಯಾನ್ ಕಂಟೈನ್ ಡಿಫ್ರೆಂಟ್ ಕೈಂಡ್ ಆಫ್ ಆಬ್ಜೆಕ್ಟ್ಸ್. ಸೊ ನಾವು ಅಗೇನ್ ದಿಸ್ ಇಸ್ ದ ರೀಸನ್ ವೈ ವಿ ಯೂಸ್ ಸ್ಟ್ರಕ್ಟ್ಸ್ ಇನ್ ಸಿ. ದಿಸ್ ಇಸ್ ದ ರೀಸನ್ ವೈ ಯು ಯೂಸ್ ಸ್ಟ್ರಕ್ಟ್. ನಾವು ಸ್ಟ್ರಕ್ಟ್ is a way where we can collect, where the entities which are being in use in real world can be collected of dissimilar data types. Dissimilar data types. Simple. Now you're quoted example now will matadaga. Let's say you are a student and your student will be having his name, the marks he scored, the average marks ಎಲ್ಲ ಇದ್ದಾಗ ನಾವು ಯಾವ ಥರ ಅದನ್ನು ಸ್ಟೋರ್ ಮಾಡ್ಬೋದು ಅರೇದಲ್ಲಿ. ಇವಾಗ ನೇಮ್ ಆಫ್ ದ ಸ್ಟೂಡೆಂಟ್ಗೆ ಒಂದು ಅರೇ ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ಅದು ಸಪ್ರೇಟ್ ಅರೇ ಸ್ಟೋರ್ ಮಾಡಿದಾಗ ಆ್ಯಂಡ್ ಸಪ್ರೇಟ್ ಮಾರ್ಕ್ಸ್ ಸ್ಟೋರ್ ಮಾಡಿದಾಗ ಆ್ಯಂಡ್ ಸಪ್ರೇಟ್ ಆವರೇಜ್ ಮಾರ್ಕ್ಸ್ ಸ್ಟೋರ್ ಮಾಡಿದಾಗ ಇಟ್ ವಿಲ್ ಬಿಕಮ್ a tedious task to retrieve the data. So what if we can combine these and collect all these dissimilar data types and make themselves into an array? ಸೊ ಅದೇ ನಾವು ಯೂಸ್ ಮಾಡೋದು ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಅದಕ್ಕೋಸ್ಕರ ಯೂಸ್ ಮಾಡೋದು. ಸೊ ದಿಸ್ ಇಸ್ ಟು ಓವರ್ಕಮ್ ದಿಸ್ ಡಿಸ್ಅಡ್ವಾಂಟೇಜ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್. So whenever we want a collection of similar or dissimilar data types, they're logically related. Again, object. An object can be logically related to its own different kind of data. Now, what is structure? Definition you deep ಹೋಗ್ಬೇಕಂದ್ರೆ structure is a collection of one or more declaration of variables of same data type or dissimilar data types grouped together as a single entity. Now, I think if you know a bit about object, you will now again correlated that to a structure. If you think a car is an object, now again, a structure will be a collection of cars or one or more variables which make up a car. Now, the variables defined inside the structure are called members of the structure or fields of the structure. This is a syntax. So in C, when you're writing a structure, this is how you code it out in your C language. So all the members can be accessed using a common name. It's a derived data type in C. Yep. Very important point. This is this line. It is a derived data type. Of course, derived data type is what we as the users or the programmers or what kind of the people who are handling this kind of data create their own data type using the primitive data types. Primitive data types, not primitive data structures, primitive data types. Int use ಮಾಡ್ತೀರಾ ಅಥವಾ some kind of um, anything other than the pre-existing data types use ಮಾಡ್ಬಿಟ್ಟು ನಮ್ಮದೇ ಆದ ನಾವು derived data type use ಮಾಡಿದ್ರೆ to make that kind of data type we use struct. Now that structure is a keyword which we are using to create the struct. This is how you this is a syntax. Just remember, if they ask this question, I don't know, it might be rare, but if they ask this question, so structure definition bariri, and you can write it in your raw words, but again, it's more preferable if you guys can handle the definitions in writing the examinations thoroughly, I guess. So ಹಂಗೆ ಮಾಡಿದಾಗೂ ಒಳ್ಳೇದಾಗುತ್ತೆ ಬಿಕಾಸ್ ಈಗ ಯು ಮೈಟ್ ಗೆಟ್ ಮೋರ್ ಮಾರ್ಕ್ಸ್, ಯು ನೆವರ್ ನೋ ವಾಟ್ ಕ್ಯಾನ್ ಹ್ಯಾಪನ್. ಸೊ ನಾವು ಸಿಂಟ್ಯಾಕ್ಸ್ ಬಂದು ಸ್ಟ್ರಕ್ಟ್ ಟೈಪ್ ಒನ್ ಟೈಪ್ ಟು ಟೈಪ್ ಟು ಬಂದು ದ ಟೈಪ್ ಆಫ್ ದಟ್ ಮೆಂಬರ್ ಒನ್, ದ ಟೈಪ್ ಟು ಬಂದು ದಟ್ ಮೆಂಬರ್ ಟುದು ಡೇಟಾ ಟೈಪ್. ಸೊ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿದ್ರೆ ನಿಮ್ಗೆ ಇನ್ನೂ ಅರ್ಥ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಅ ಸ್ಟ್ರಕ್ಚರ್, ದಿಸ್ ಇಸ್ ಅ derived data type which we are deriving for a student. A student can have a name, a student has his own marks, and a student can have his average marks. So this is a derived data type called student, illa student, and which contains their own entities. Note, we all know that variables are defined in the beginning of the function or before the function definition. Of course, we have to declare first, then use. Use ಮಾಡಾದ್ಮೇಲೆ declare ಮಾಡಿದ್ರೆ it's pointless and there will be an error which is being going to be thrown by the compiler. Now, what are the different types of structures? There are tagged, tagless, and type defined. I'll go very roughly throughout this because it's simple to understand. It's the key differentiator ಏನಂದ್ರೆ ನಾವು ಎಲ್ಲಿ ಹೆಸರು ಯೂಸ್ ಮಾಡ್ತಿದ್ರಿ ಎಲ್ಲಿ ಹೆಸರು ಯೂಸ್ ಮಾಡ್ತಿಲ್ಲ ಅದೇ main key differentiator. Tagged is in the structure definition, the key struct word can be followed by an identifier. The identifier is called tag name. The structure definition associated with the tag name is called tag structure ಅಂತ ಇಲ್ಲಿ ಬರ್ದಿದ್ದಾರೆ. So the main gist of it, again, I'll simply dumb it down. Struct ನಾವು create ಮಾಡುವಾಗ, if I randomly create a struct, and if somebody who is trying to develop with me, he is trying to develop another object for another struct using that struct, if there is no name for that struct, then how will we understand that what kind of structure am I using to define that object? So that is a really bad heuristic rule, rule of thumbs, right? So syntax ಯಾವತ್ತು ಬರೆಯುವಾಗ, so what did they come up with? Instead of randomly creating struct, give it a name, tag the structure, so that the tag name will be followed by our struct keyword. ಆ ಕೀವರ್ಡ್ ಆದ್ಮೇಲೆ ನೀವು ಯಾವ ಟ್ಯಾಗ್ ನೇಮ್ ಕೊಡ್ತಿರೋ that structure name would have been associated with the tag name. So this is the same example student ಗೆ. So this student will have this kind of character, this kind of int, and the float is the entities of that struct. Now structure declaration. Declaration ಅಂದ್ರೆ ಏನು? Let us understand between let us understand what is meant by defining a structure and declaring a structure. Right. Let's say we are defining a structure ಅಂದ್ರೆ ನಾವು ಆ ಡೇಟಾ ಟೈಪ್ ಏನು ನಾವು ಯೂಸರ್ ಡಿಫೈನ್ಡ್ ಅಥವಾ ಡಿರೈವ್ ಡೇಟಾ ಟೈಪ್ ಏನು ಕ್ರಿಯೇಟ್ ಮಾಡ್ತಿದ್ರಿ ಬೇಸಿಕಲಿ ಯೂಸಿಂಗ್ ದ ಸ್ಟ್ರಕ್ಟ್ ಕೀವರ್ಡ್, ದಟ್ ವಿಲ್ ಬಿ ಜಸ್ಟ್ ದಿ ಡೆಫಿನೇಷನ್. ಮೆಮರಿ ಇನ್ನೂ ರಿಸರ್ವ್ ಆಗಿರಲ್ಲ ಅದಕ್ಕೆ, ಮೇನ್ ಮೆಮರಿ ಆಗಲಿ ಅಥವಾ ಸೆಕೆಂಡರಿ ಮೆಮರಿ ಆಗಲಿ. ಬೈ ಡಿಫೈನಿಂಗ್ ಎ ಸ್ಟ್ರಕ್ಚರ್ ಮೆಮರಿ ವಿಲ್ ನಾಟ್ ಬಿ ರಿಸರ್ವ್ಡ್. ಅಂದ್ರೆ ಈ ಮೆಂಬರ್ಗಾಗ್ಲಿ ಮೆಂಬರ್ ಟು ಯಾವುದಕ್ಕೂ ಆಗಲಿ ದೆರ್ ವಿಲ್ ಬಿ ನೋ ರಿಸರ್ವೇಶನ್. ಜಸ್ಟ್ ಆ ಸ್ಟ್ರಕ್ಚರ್ ಅನ್ನೋದು ಡಿಫೈನ್ ಆಗಿದೆ. ಮೆಮರಿ ಇಲ್ಲಿ ಓನ್ಲಿ ಅಲೋಕೇಟೆಡ್ ವೆನ್ ದಿ ಸ್ಟ್ರಕ್ಚರ್ ಇಸ್ ಅಸೋಸಿಯೇಟೆಡ್ ವಿತ್ ವೇರಿಯಬಲ್ಸ್. until and unless you store something using that struct, ಅಲ್ಲಿ ಗಂಟ memory won't be allocated. So simple, it's logical, nothing out of the box. The process of reserving the space for members of a structure is called structural usage. So ಏನಾದ್ರು ಸ್ಟೋರ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಜಾಗ ಬೇಕು. Now let's say this character takes 1 byte in the memory, so it requires now, but still we are using maximum which can contain 10 bytes, in the sense if we leave the last, you know, null pointer at the last. So you can consider that, yeah, that name will be containing up to 9 character. So now this should have its own space of 10 bits, or 10 bytes. Now Intel ನೋಡಿದ್ರೆ generally 64-bit architecture ಅಲ್ಲಿ 4 bits ಇರುತ್ತೆ, 2 bits will be 32. So let's say let us assume C ಅಲ್ಲಿ 4 bits for int, again 4 bits for 4 bytes for int and 4 bytes for float. So now ಇದಕ್ಕೆ ಅದರದಾದ ಒಂದು ಜಾಗ ಅಲೋಕೇಟ್ ಮಾಡಬೇಕು. ಬಟ್ ಅದನ್ನ ಹೆಂಗ್ ಅಲೋಕೇಟ್ ಮಾಡ್ತೀರಾ? ಓಕೆ, ಡೆಫಿನೇಷನ್ ನಲ್ಲಿ ಏನು ಅಲೋಕೇಟ್ ಆಗಲ್ಲ. until and unless the variables have their value, ಅವಾಗ allocate ಆಗುತ್ತೆ, ಗೊತ್ತಾಯ್ತು. That is what structure declaration is. But how is it allocated? How is it allocated? This is very important point, and it's good if you know, even in different applications, low level applications, this will be helpful. Let's see. A block of memory is allocated for structure variables. A block of memory ಅರ್ಥ ಏನಂದ್ರೆ, let's say the name add 10 bytes and the marks at 4 and the float of average at 4. Now e block ಇದೆಯಲ್ಲ, ಈ block this block is associated to that student. ಸೊ ಆ ಸ್ಟೂಡೆಂಟ್ಗೆ ನಾವು ಅಸೋಸಿಯೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. And what is this here? We are just declaring a name for this tagged structure. CSC is a kind of ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಅಂತ ಅನ್ಕೊಂಡು, ಸೊ ದಟ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಯಾವುದೇ ಸ್ಟೂಡೆಂಟ್ಗೆ ಈ ತರ ಒಂದು ಸ್ಟ್ರಕ್ಚರ್ ಇದೆ ಅನ್ನೋ ಒಂದು abstract thinking. How to initialize tag structure? Structure initialization, it's basically the same thing. Now, the process of initializing the members of a structure is called initialization. During initialization, all the data items must be enclosed with braces. As we are going to be storing some kind of values in that predefined structure, ನಾವು ಅದನ್ನ ಹೆಂಗೆ ಇನಿಷಿಯಲೈಸ್ ಮಾಡ್ಬೋದು ಅಂದ್ರೆ ಏನಾದ್ರೂ ವ್ಯಾಲ್ಯೂ ಅದಕ್ಕೆ ಹಾಕ್ಬೋದು ಅಂದ್ರೆ using this, right? Using this kind of syntax where you create an object A which will have their name, their marks, and their average marks, right? And this is how it will be stored in the memory, in that block of memory which is allocated to that student A and that student B. So I wouldn't go in depth. And tagless is where you don't use any kind of tags in this syntax. It's not a conventional method, but again, it exists. You can use aliases. Whatever you write here will be considered as alias. Now, how and when memory is allocated for structure variables. Again, ಅವಾಗೆ ಮಾತಾಡಿರೋದೇ ಸೇಮ್ ಇದೆ. Now, let's slightly dive a bit more into type defined structure. Same structure ಹೆಂಗ್ ಡಿಫೈನ್ ಮಾಡ್ತಿರೋ ಹಂಗೆ, but why is type defined structure useful? Again, it's more about the aspect of understanding your code and how well documented your code is. ನಾವು ಸ್ಟ್ರಕ್ಚರ್ನ ಸ್ಟ್ರಕ್ಟ್ ಸ್ಟೂಡೆಂಟ್ ಅಂಡ್ ಅಂತ ಮಾಡಿದಾಗ, ಸೊ ಎವ್ರಿ ಟೈಮ್ ನೀವೇನಾದ್ರೂ ಅದನ್ನ ಯೂಸ್ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಕ್ರಿಯೇಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ, ಸೊ ಎವ್ರಿ ಟೈಮ್ ನೀವೇನ್ ಮಾಡ್ಬೇಕಾಗುತ್ತೆ ಅವಾಗ, ಎವ್ರಿ ಟೈಮ್ ಯು ಹ್ಯಾವ್ ಟು ಸೇ ದಟ್ ಯಾ ಎಲ್ಲೋಯ್ತದು, ಎವ್ರಿ ಟೈಮ್ ಯು ಹ್ಯಾವ್ ಟು ಸೇ ಸ್ಟ್ರಕ್ಟ್ student A equals to this, struct student B equals to this. Now this is time consuming and tedious. ಸೊ ಇದನ್ನ ನಾವು ಹೆಂಗ್ ಚಿಕ್ಕದ್ ಮಾಡ್ಬೋದು ಅಂತ ಏನಾದ್ರು ಯೋಚನೆ ಮಾಡಿದಾಗ, ದೆನ್ ಕಮ್ಸ್ ದ ಟೈಪ್ ಡೆಫ್. ಟೈಪ್ ಡೆಫ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಟೈಪ್ ಡಿಫೈನ್ಡ್ ಅನ್ನೋ ಒಂದು ಕೀವರ್ಡ್ ನಾವು ಯೂಸ್ ಮಾಡಿ, ಅದಾದ್ಮೇಲೆ ಆರ್ ಓನ್ ಕೀವರ್ಡ್ ಸ್ಟ್ರಕ್ಟ್ ಮಾಡಿದಾಗ, ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಗಿವಿಂಗ್ ಯುವರ್ ನೇಮ್ ಇಯರ್, ಅಲಿಯಾಸ್ ಆಗಿ ಕೊಟ್ಬಿಡಿ at the end. If you give this as an alias at the end, now with this type def, it's called type def structure. This is very useful, and this whole structure can be identified only through this alias. So ನೋಡಿ, instead of creating struct the student and A, you can just create type id v1 v2. Now this v1 v2 till vn are all the entities or objects which are which have been created using the derived data structure type id. So this is very easy to understand, it's very easy to read, and again they have their own idea and users behind their approach. Now the main concept, if you come to the main concept,